Hi, my name is Ann Byerly, and I'm the Deputy Director of Public Works for the City of Golden. Today, I'm here representing the Upper Clear Creek Watershed Association, or UCWA, which is a collection of water and wastewater providers and other interested stakeholders in the Upper Clear Creek watershed. I am thrilled to present our pre-fire planning study for consideration at the 2021 Engineering Excellence Award. The Upper Clear Creek watershed is a critical water resource for the Front Range and communities in Gilpin and Clear Creek County. If a significant wildfire were to occur, it would have major impact on the area. Impacts that would include post-wildfire flooding, debris flows, and obviously economic impacts. In order to protect the safety, health, and welfare of the community, it is really important to plan for wildfire scenarios and identify and assess the risk to existing infrastructure and to prioritize projects that reduce potential impacts. There were several goals that were imperative to developing a successful pre-wildfire planning study. It was important to establish a robust stakeholder engagement program between the UCWA members and external entities, which in this case included the U.S. Forest Service, the Colorado State Forest Service, and the Colorado Water Conservation Board, and the emergency management community from the counties involved. This would allow the project team members to integrate information from UCWA member sources and identify and assess sustainability and resilience in a post-wildfire scenario relative to the changes in hydrology and hydraulics at critical high-priority locations or stream segments. In addition, it was important to the project the stakeholder input was used to form non-technical drivers and decision factors for prioritization. Analyzing a suite of options to manage forest and fuels, to restore and improve stream channels, and assess and mitigate the wildland-urban interface was a key component of the project. The desired outcome included the formation of multi-objective partnerships around critical resources and infrastructure values. Throughout the duration of the project, the team implemented a number of creative, unique, and innovative solutions to not only address the technical challenges, but to generate consensus from a diverse set of stakeholders while we were all working from home. The end product is a plan that will protect and enhance public health, safety, and welfare for years to come. The watershed-based and stakeholder-driven process that we use can be implemented can be used as a model and implemented for other communities throughout Colorado to improve resiliency. So on behalf of UCWA and our many, many project partners, we would really like to thank CASFM for considering the Upper Clear Creek Watershed Pre-Planning Fire Study as a finalist for the 2021 Engineering Excellence Awards.
Clear Creek is located in the north-central Front Range of Colorado within the South Platte River Basin. The creek flows from west to east, extending from the Continental Divide near Loveland Pass on the western edge to the confluence with the South Platte River. This plan covers the upper mountainous portion of Clear Creek from the headwaters to the city of Golden, where Clear Creek exits Clear Creek Canyon. Nearly two-thirds of the 400 square mile Upper Clear Creek watershed lies within the boundaries of the Arapahoe and Roosevelt National Forest, so a large portion of the watershed is relatively undisturbed by human development. However, the steep, rugged topography has led to most human development occurring along stream corridors, which has resulted in impacts to water quality, aquatic life, and riparian habitat. The Clear Creek corridor has been extensively developed for transportation, including railroads, U.S. Highways 6 and 40, and Interstate 70, which was constructed along Clear Creek in the 1960s. A number of communities and towns are located along Clear Creek, including the city of Idaho Springs, the town of Georgetown, the town of Empire, the town of Silver Plume, the city of Blackhawk, and Central City. The upper watershed also includes portions of 3 counties, including Clear Creek County, Gilpin County, and Jefferson County.
The path to a comprehensive management plan involving the input of stakeholders and technical experts begins with defining the goals and structure of the plan. The project team met with stakeholders early in the study to define common goals and develop a vision for the future of the watershed. The plan approach included 3 primary steps: project identification, technical analysis, and plan development. During the problem identification phase, stakeholders identified what the plan needed to address and the types of projects which were necessary to protect the health and safety of communities within the watershed. Technical analysis included the identification of the data and analyses required to effectively evaluate the issues in the watershed and meet project needs. Appropriate tools and methods were developed to evaluate the results. The plan development used a tailored decision-making process to organize, manage, and prioritize projects. Projects and issues identified during the study were connected to potential solutions to provide a comprehensive comparison of projects to help stakeholders and resource managers prioritize projects with respect to regional needs and objectives. The project goals fell into 4 primary areas: protecting public health and safety, protecting drinking water, identifying critical infrastructure, and reducing flood risk. As with any publicly funded planning study, the first and foremost goal is to maintain or improve public safety. In the case of our study, this not only includes safety during a natural hazard event, such as a wildfire or a flood, but also safety for the general public on a day-to-day basis, as they interact with man-made and natural infrastructure. Research has proven that interacting with nature leads to healthier lives, and we are now seeing record visitation numbers for national and state parks, as well as other public lands, such as national forests. These factors were both key considerations for the stakeholders during the project visioning process. The western United States has been under the pressure of extreme drought for several years, and it is estimated that this drought period could become the new normal. With this reduction in overall water available for human use, it is imperative that we protect the quality of the water that is available to us, while also maximizing efficiencies. Since many of the stakeholders for the study are water providers, it is paramount for them to protect their source water. For some communities, the water that is diverted from Upper Clear Creek is their only water supply source, presenting a tremendous risk should a wildfire impact their ability to divert or treat water. Identifying, protecting, and fortifying critical infrastructure was a common goal among the various stakeholders. We've seen throughout the summer post-fire flooding and debris flows can cripple transportation infrastructure, which has significant economic ripple effects on local communities as well as broader state and national impacts. Other utility infrastructure, such as sanitary sewers, potable water systems, electrical transmission and distribution systems, can also be impacted. The study aimed to identify these risks and find potential mitigation projects to better manage them. Have you heard the song Fire in the Flood? It is true that flood events are almost a certainty following a wildfire. However, floods can also occur without a precursor wildfire, so identifying ways to reduce the risk of flooding would simultaneously improve the resiliency of the system to bounce back from a wildfire and account for potential increased hydrology. The project stakeholders wanted to look for those collaborative opportunities to leverage pre-disaster planning to protect communities.
In order to mitigate pre- and post-fire risks to the watershed and infrastructure, the study identified 6 distinct project types: stream restoration, stream corridor preservation, water quality and debris facilities, flood risk reduction, vulnerable utilities, and forest management. Each project type may focus on different objectives, but collectively, they improve the overall health of the watershed and improve resiliency. Let's start with stream restoration. Stream restoration looks at portions of Clear Creek and its tributaries which are unstable and would require restoration, while stream corridor preservation focuses on sections that are currently stable that should be preserved. Both of these add resiliency to the system should a fire occur. When stream reaches are in a stable condition, they are much more capable of bouncing back from stressors compared to reaches which are already degraded. On to water quality and debris flow facilities. These facilities are locations which were identified where sediment and debris would naturally fall out or become trapped. Identifying these locations now could help streamline permitting or allow for quick equipment mobilization in a post-fire scenario. Only a few of these project types were identified during this study. However, the USGS is currently working on an analysis and peer-reviewed paper which would identify portions of the watershed which are at highest risk of post-fire debris flows. These areas will be perfect for water quality or debris flow facilities.
Flood risk reduction projects primarily focus on culverts or bridges, which may be undersized or in poor condition. In a post-fire hydrologic scenario, undersized crossings or those in poor condition are at the greatest risk of failure or creating debris dams, which can have impacts outside of the immediate stream corridor. Identifying locations which are most critical is key to prioritizing the many project needs. Vulnerable utilities include utilities which cross the stream corridors, either above the stream via an aerial crossing or underneath the stream. In both cases, these utilities could be at risk in a post-fire flood scenario. In addition, stream diversions are also vulnerable utilities that could blow out or become persistently clogged in a post-fire scenario. Healthy forests are less susceptible to catastrophic wildfires. Forest management is a broad term which refers to aiding the forest to stay healthy or improve its health through tree thinning, succession, controlled burns, and other methods. Both the U.S. Forest Service and the Colorado State Forest Service continuously identify areas of the forest that would benefit from more active management approaches. These agencies identified most of the forest management projects in this study and are looking to leverage this study and establish our collaborative process to help identify more.
In the past, visual stream assessment was limited to aerial photography or physically walking the stream reaches. Data from LiDAR and other sources has allowed for the creation of relative elevation models, or REMs, which has opened up the possibilities of desktop visual stream analysis. REMs are particularly good at identifying reaches that are heavily vegetated and well connected to the floodplain, such as this reach behind me. The heavy vegetation makes analysis difficult when you're just using aerials or even visually inspecting the areas. REMs can also help identify alluvial hazard zones, which are areas where the stream threatens to change course during large flood events or when debris flows block the existing channels.
Prior to this study, Matrix improved upon the previous REM creation methodologies and devised a way to generate REMs far quicker, more than tripling the speed at which REMs could be created, while at the same time increasing the fidelity of the REMs. This tweak to the current methodology has been adopted into the Colorado Water Conservation Board's REM creation methodology. The ability to rapidly create REMs allowed for the production of REMs for 6 reaches within Upper Clear Creek County watershed, covering over 50 miles of stream corridor. REMs are invaluable for large-scale studies such as this one, as they can be used to evaluate long reaches quickly and efficiently, highlighting sections of streams that are particularly healthy or unhealthy. These REMs were heavily referenced in the analysis and identification of 3 of the project types: stream restoration, stream preservation, and water quality and debris flow facilities. Shown here is an REM of a reach where the stream corridor is healthy and well connected to the floodplain. While this area is visible on aerials, the REM visually highlights the health of this particular reach. In this section of Clear Creek, the heavy vegetation hides the fact that this stream corridor is also healthy and well connected to the floodplain, which would have been difficult to evaluate based on aerials alone. This particular reach also hides an avulsion hazard zone, seen here. In a flood event, the creek could change course and create an avulsion channel. The REM allows for quick identification of these particular hazards. Understanding the power of the REMs, Matrix began looking at ways to expand upon the value of this tool. Using bankful area and slope data generated during the creation of the REMs, Matrix was able to produce unit stream power data. Using unit stream power, a delta unit stream power layer was created that looked at the change in unit stream power from section to section, effectively identifying areas of aggradation and degradation. Aggradational and degradational areas were then closely analyzed, and some aggradational areas were identified as stream preservation projects, and some degradational areas were identified as stream restoration projects. As can be seen here, the stream power data highlights a location where there is a drastic increase in stream power, potentially leading to degradation. While this particular location seems stable, this dataset can help to quickly identify locations that could degrade over time or degrade during a post-fire flood event. The REM also helped to identify locations in the stream where debris and sediment would naturally fall out. These locations were selected as sites for water quality or debris flow facilities. The REMs allowed for topology to be taken into account during the selection of these project sites, paving the way for quick mobilization in a post-fire scenario. These tools allow for quick and accurate analysis of stream corridors and can help identify areas where rapid mobilization and project construction can drastically increase the resiliency of the stream corridor and decrease the impact that fire can have on a watershed. Both of these solutions for project identification can easily be replicated by communities throughout Colorado.
In order to focus planning efforts, the team needed to identify where projects are most needed by prioritizing subbasins. Then, potential projects needed to be identified based on criticality and location. Finally, the identified projects needed to be scored based on technical merit and then ranked based on non-technical drivers identified by the stakeholders in the decision matrix. The first step was to improve the granularity of previous analysis and datasets. For example, most of the previous studies utilized HUC-12 subwatersheds, which have an average size of 40 square miles. While this scale is sufficient for broad-scale watershed comparisons across the state, This project needed smaller watersheds in order to be efficient and focus pre-fire mitigation strategies in the areas where they are most needed. Utilizing existing LiDAR and topographic data, the project team further subdivided the subwatersheds into custom Huck 14 basins. A target area of 5 square miles was set, coinciding with typical U.S. Forest Service Burned Area Emergency Response Team subwatersheds during a post-fire assessment. The subbasins were prioritized based on 5 technical criteria. The first category was wildfire risk, and is identified by the Colorado Wildland Risk Assessment Update. This was a rasterized data set, which was processed and scored per subwatershed. Wildland-urban interface risk was also identified by the same document and identifies developed areas that are encroaching into the forest, which are known to be at higher risk for starting a wildfire. The next category quantified the amount of forest management that has occurred since 2008. Subwatersheds which have had tree thinning or other treatments scored low, while subwatersheds which have had no treatments scored high. Critical infrastructure was the next category and quantified the number of facilities within the subbasin. Those with higher counts received higher scores. The water supply risk category quantified the amount of a subwatershed that was in close proximity to or contained a municipal water diversion point. Subwatersheds whose areas contained large amounts of tributary area to those diversions scored highest. The final category included the runoff potential of a subbasin in a post-fire scenario. Subwatersheds which have the greatest potential to increase runoff volumes scored highest. Several approaches were utilized to assemble the list of potential projects. To start, projects that had been identified in other studies were included, such as potential stream restoration projects in Upper Leavenworth Creek, identified by the U.S. Forest Service, and potential forest management projects in the Floyd Hill area identified by the Colorado State Forest Service. Potential projects were also identified during the stakeholder engagement process to understand the criticality of certain facilities, such as treatment facilities, and their impact to the normal operations of a town or district. Lastly, the REM tool discussed previously was used to identify potential project locations. It is anticipated that new projects will be identified in the future as needs change and as previously identified projects are completed and taken off the list. After all of the potential projects were identified and scored based on their technical merit, the top quartile was then screened through the decision matrix that was developed during the stakeholder engagement process. The decision matrix helped better quantify the on-the-ground situational awareness that many stakeholders understood. Once the decision matrix scoring was complete, 40 ranked projects were output and constitute the heart of the actionable list which came out of the study. Stakeholders are actively working on implementing the first few projects in 2022. It is critical for any planning project to engage the stakeholders in order to be effective. Because of the pandemic, the team had to get creative on how to engage with numerous stakeholders and extract the values and critical issues affecting the watershed. The team used new tools such as virtual meeting platforms including Zoom and Menti to develop the robust list of core values and critical issues identified by over 42 stakeholders. By identifying these critical issues and developing evaluation criteria that directly link to the prioritization of projects, the study greatly improves its likelihood of success and implementation of projects for years to come.
This study can serve as a model for other communities by exemplifying how much data communities already have and how they can use that data to create a pre-fire plan. Communities around the state and the country can conduct similar pre-fire studies to increase their own resiliency during the coming years when fire risks are increased. There were a number of key elements that made the Upper Clear Creek Watershed pre-fire planning study a success, and these same elements can be utilized by organizations throughout the state on similar projects. This study utilized existing publicly available data, which can be accessed by other entities or regions who can leverage it as necessary based on local needs. Some site-specific data was generated by local operators, field personnel, and long-standing stakeholders who carried legacy knowledge with them. Documenting this legacy knowledge and layering it over existing data was an important step in the success of the plan. Floods and fires do not respect governmental boundaries on a map, so it is imperative that local entities need open lines of communication to collaborate prior to the disaster so that they can collectively plan and better respond during and after a disaster. Developing boundaries based on watersheds helps bring these entities together early in the process. Without the input of a broad cross-section of stakeholders, a community can end up with a plan that is uninspired at best and divisive at worst. Our project's approach of developing a comprehensive decision matrix built from the ground up with a mission statement, core values, and critical issues helps stakeholders see the issues from different perspectives and find common ground on goals. In addition, completing the project during a global pandemic demonstrated that valuable feedback could be collected in a virtual environment and in fact may increase participation by improving accessibility. In most cases, fires affect watersheds as a whole, and ensuring that communities within that watershed align their goals and priorities, watershed solutions can be achieved. If other watershed-based groups similar to UCWA can embrace these elements, then Colorado's overall resiliency can be improved.
On behalf of Matrix and UCWA, thank you for including us as a finalist for the Engineering Excellence Award in 2021. And remember, Smokey the Bear says, only you can prevent forest fires.
But he also says only you can vote for this project, so please do.